So to start talking about the vector dot product, let's start with the definition. Say we have two vectors, and these can be arbitrary 3D vectors. We'll call one A, and we'll call the other B. Then A dot B is defined, and we denote that with the triangle over the equal sign. A dot B is defined as the product of the magnitude of A, the magnitude of B, and the cosine of the angle between vector A and vector B. So if we look at these two vectors, we have to think, what is the angle between them? First, I'll draw what it's not. This angle here is not the angle between A and B. We have to redraw A and B so that they're tail to tail like this. Now we can call this interior angle theta. And here I've labeled also the length, or the magnitude, of vector B and vector A. A common thing we might want to do with this definition is to solve for the angle theta between the vectors, given a dot product computation, which we'll talk about later. So we can just rearrange this expression and get that theta is the arc cosine of the dot product of A and B divided by the product of their magnitudes. This definition is also helpful for explaining what it means to square a vector. We have to define what that means. In our notation, that's going to mean that it's the magnitude of V squared. So now if we look at the dot product definition, we can say, well, if we're taking the dot product of V with itself, then the magnitude portion is taken care of. What about the cosine portion? If we look at a vector V and the angle that it makes with itself, we can see that the angle is 0, and so cosine of 0 becomes 1. So then we see that V squared, by definition, is the magnitude of V squared, which matches the definition for the dot product. So we can compute V squared as V dot V. And similarly, sometimes we will want the magnitude of V, which is just the positive square root of V dot V. So we've only really talked about this definition, and you might be wondering how to compute V dot V, and we'll talk about that in the next sections.